Hey there, in this video I'll be talking about the current divider rule. This rule is used to calculate the current through any individual resistor that is in a parallel combination. Okay, so we have a circuit, there's a current source, and there's R1, resistor 1 and resistor 2. So there's a current in the circuit, I that is flowing. This is the maximum current coming from the source. And then this is the junction. So this is the point where the current splits into two. So current goes to R1 and R2. It varies according to the value of the resistance. The more the resistance, the less the current. So the current going to R1, let's call that I1. The current going to R2, let's call that I2. So this is actually really simple. So to find I1 would equal to the total current IT times with the resistance of the opposite resistor that is in parallel, R2. For R1 we're going to take the value of R2 as a numerator, R2 over the sum of R1 plus R2. So this would be I1. Now I2 is the same, except IT times is the same, except we take the value of R1 as a numerator, R1 over the sum of R1 plus R2. That's I2. Okay, now some people get confused when there's a voltage source instead of a current source, or when there are more resistors in the circuit. So we have to use the same rule like twice. So first we get the equivalent resistance of that branch. Suppose like if it was like this, another one connected to this, then we take the equivalent resistance of this and then do the current divider rule again and find the total current. And if there's a voltage source, we find the equivalent resistance of all of this, and then use the KVL rule. I is equal to V over R, and find the total current in the circuit, and then use current divider rule to calculate each the current flowing to each resistor in parallel combination.